A Harvard scientist is sounding the alarm. An interstellar visitor, 3I Atlas, is shedding metallic alloys that just shouldn't exist. Real data from our best telescopes shows atomized nickel streaming from its core, but with practically zero iron, a chemical fingerprint that really defies everything we know. Harvard's Avi Loeb is asking the question no one else wants to: if these metals aren't natural, what does that mean? The answer could upend our place in the universe, so let's explore this together. The discovery of 3I Atlas. What would you do if you saw something moving at 130,000 miles per hour that wasn't supposed to be there? On July 1st, 2025, the Atlas survey team in Chile spotted a faint, fast-moving speck. The math instantly told a story that just didn't fit any known playbook. Its path wasn't just a long loop, it was hyperbolic, with an extreme eccentricity that confirmed it was a visitor from deep space, moving too fast for the sun to ever capture it. This wasn't a comet on a return trip. Astronomers combed through archival data and found earlier images, firming up its trajectory. The object was born far beyond our solar system, possibly somewhere near the galactic center. By the time it was discovered, it was already inside Jupiter's orbit, making a one-time slingshot around our sun before it shoots back into the void. Its incredible velocity confirmed it. 3I Atlas is only the third confirmed interstellar object ever seen, a messenger from another star that will never return. This isn't just a rock, it's a clue from an unknown part of the galaxy. The nickel mystery. Imagine finding a fingerprint that doesn't match any person on Earth. That's what astronomers found in the light from 3I Atlas. Almost as soon as it crossed Jupiter's orbit, spectrographs detected strong signals of atomic nickel streaming from its coma. But the real shock wasn't what was there, it was what was missing. There was virtually no iron. This isn't just unusual, it's chemically bizarre. In every meteorite and comet we've ever studied, nickel and iron are cosmic partners, forged together in the hearts of dying stars and locked into the same minerals. When a comet heats up, they should be released together. Yet, data from the Very Large Telescope showed nickel vaporizing off the object, while iron was a no-show. Harvard astrophysicist Avi Loeb was the first to publicly highlight how unnatural this is. He argues that separating nickel from iron requires industrial processes here on Earth. In space, it's unheard of. It's like finding a gold ring without any trace of the other metals typically alloyed with it. This single chemical clue is so potent that it forces a profound question. Are we witnessing a freak of nature, or is this a deliberate engineered signature? Carbon dioxide dominance. Just when the nickel-iron problem had scientists scrambling, the James Webb Space Telescope delivered another bombshell. Pointing its powerful infrared instruments at 3I Atlas, a team of astronomers analyzed the gases in its coma, and found that carbon dioxide was completely dominating the mix. The measured carbon dioxide to water ratio was a staggering 8-to-1, the highest ever recorded for any comet, whether from our solar system or beyond. To put that in perspective, typical solar system comets have CO2 levels around 4% of their water content. Here, CO2 is the main ingredient. This wasn't a fluke. The readings remained consistent across multiple observation sessions as the object neared the sun. While other gases like carbon monoxide were present, nothing came close to the CO2 spike. This kind of chemistry just doesn't align with our models of comet formation. Some researchers propose that its unique composition is the result of being cooked by cosmic rays over a billion-year journey. Others wonder if it's a clue to the specific conditions of its home star system. But the question remains, does this unprecedented chemistry point to nature at its most extreme, or is it another sign that something else is at play? The Oumuamua precedent. This isn't the first time an interstellar visitor has broken all the rules. Back in late 2017, astronomers detected one Oumuamua. At first it seemed like an asteroid, but its behavior was deeply strange. As it swung past the sun, it began to accelerate, pushed by a force that wasn't gravity. The problem? There was no visible outgassing, no tail, no coma, none of the typical rocket-like effects a comet uses to speed up. Oumuamua left nothing behind. Its light curve also suggested a bizarre shape, perhaps 10 times longer than it was wide, like a cigar or a flat pancake. The scientific community scrambled for an explanation: exotic ices, hydrogen outgassing, fractal dust. But no single natural theory fit all the data. It was into this debate that Harvard's Avi Loeb stepped, arguing that Oumuamua's shape and acceleration were consistent with an artificial object, specifically, an ultra-thin solar sail designed to ride the pressure of starlight. The idea caused a firestorm, but it cemented a critical precedent. When objects from other stars arrive, we shouldn't assume they'll play by our rules. Oumuamua prepared the scientific world to ask bolder questions. Ancient sky metal. Humanity's fascination with metals that fall from the sky is not new, it's ancient. Over 5,000 years ago in ancient Egypt, craftsmen hammered tiny beads from a mysterious iron that they didn't mine from the earth. Modern analysis of these beads from the Giza cemetery reveals a nickel content of nearly 30%, far higher than any terrestrial ore. This was the unmistakable signature of meteoritic iron. The story gets even more incredible with the dagger found in the tomb of King Tutankhamun. Discovered in 1925, the pristine iron blade was a mystery for decades. Finally, X-ray analysis confirmed its celestial origin. The blade contained 11% nickel and traces of cobalt, a composition that matched iron meteorites. The Egyptians even had a name for this divine material, iron of the sky. It was rarer and more valuable than gold, reserved for pharaohs. This history matters because it establishes a fundamental contrast. Terrestrial iron ores almost never exceed 4% nickel. Meteoritic iron, however, is rich in it. The same questions our ancestors faced, what is this strange metal and where did it come from, are echoing today as we analyze the impossible alloys of 3I Atlas. Kilonova formation theory. So if not aliens, what could possibly create pure nickel vapor in space? The answer might lie in one of the most violent events in the universe, a kilonova. This is what happens when two neutron stars, the ultra-dense corpses of massive stars, spiral into each other and collide. The resulting explosion is so powerful, it forges heavy elements through a process of rapid neutron capture known as the R process. In 2017, the gravitational wave event JWST gave astronomers their first direct look at this process, confirming that neutron-star mergers create vast quantities of heavy elements like strontium, gold, and platinum. Nickel is also created in this cosmic furnace. Crucially, depending on the chaotic conditions of the explosion, some models predict that patches of the ejected debris can be exceptionally rich in nickel while being poor in iron. These aren't the slow-cooked metals from normal stars. They are forged in seconds and blasted into space. If 3I Atlas condensed from such a cloud of debris, it would carry a chemical fingerprint completely alien to our solar system. This provides a natural, albeit spectacular explanation for its strange composition. Asymmetric supernova theory. So, there's another natural forge out there in the cosmos, violent enough to potentially explain 3I Atlas's strange chemistry, an asymmetric supernova. You see, not all stars meet their end in neat spherical explosions. Some, well, they rip themselves apart in these lopsided blasts that fling elements out in jets. The supernova remnant W49b is a perfect example of this. X-ray maps from the Chandra Observatory show that iron is packed tightly near the remnant's core, while other elements like sulfur and silicon are distributed more broadly. This kind of uneven explosion, it completely changes the rules of how metals are scattered into space. In these chaotic events, the inner layers of the star, where iron and nickel are made, don't mix evenly. Instead, high-speed plumes can punch through the star's outer layers, carrying specific elements with them. And if nickel happens to be concentrated in the path of one of these jets, it can be ejected in bulk, leaving most of the iron trapped behind. So, if 3I Atlas formed from a fragment blasted out by such a supernova, it could have started its journey as a chunk of nearly pure nickel. This provides a second plausible, though very rare, natural path to its bizarre composition. Statistical improbability. Beyond its strange chemistry, the path of 3I Atlas through our solar system is so unusual it's hard to ignore. Avi Loeb and his collaborators ran the numbers, calculating the probability that a random interstellar object would have a trajectory that takes it unusually close to Venus, Mars, and Jupiter, all in a single pass. The result was a probability so small it's almost zero, about 0.005%. That's like flipping a coin 15 times and getting heads every single time. To Loeb, this really strains the definition of coincidence and starts to look like a pattern. The object's path is nearly flat relative to the solar system's plane, but it's moving backward or retrograde against the flow of the planets. This combination allows it to skim past the inner worlds in a way that looks suspiciously like a survey flight. Critics argue that in a vast universe, rare events are bound to happen, but Loeb counters that if the odds are 1 in 20,000, and we've only seen 3 interstellar visitors so far, something doesn't add up. When you combine this improbable trajectory with the engineered-looking metals, Loeb argues it's time to take the artificial origin hypothesis seriously. The Golden Record Parallel. Could 3I Atlas be a message in a bottle? In 1977, NASA launched the Voyager 1 and 2 spacecraft, each carrying a golden record. This was a project led by Carl Sagan, intended as a time capsule for any extraterrestrial civilization that might find it thousands of years from now. The records contain sounds and images of Earth, music from various cultures and scientific diagrams, a snapshot of humanity etched onto a durable physical object. Sagan said, "The launching of this bottle into the cosmic ocean says something very hopeful about life on this planet." Now consider 3I Atlas, an object loaded with alloys and compounds that don't fit natural recipes on a trajectory that seems too precise. The parallel is striking. What if its message isn't written in grooves on a record, but in the very ratios of its elements? A physical archive designed to survive a journey of millions of years. If its composition is intentional, then 3I Atlas isn't just a visitor. It's a courier carrying a record of another world's chemistry, and maybe even its technology. Atomic messages. What if we've been looking for the wrong kind of message? For decades, the search for extraterrestrial intelligence has focused on radio waves and light signals. But what if an advanced civilization chose to send a message encoded in matter itself? This is the provocative idea that the anomalies of 3I Atlas force us to consider. On Earth, scientists are already developing methods to store information using the ratios of isotopes in molecules, creating a kind of atomic fingerprint that can be read with a mass spectrometer. In biology, DNA stores vast amounts of information in a sequence of 4 chemical bases. Some theorists now wonder if the periodic table itself could be used as a sort of cosmic QR code. By arranging isotopes in a pattern that nature would never produce by chance, a message could be baked into a physical object. This message would be incredibly durable, immune to cosmic noise, and capable of surviving for billions of years. Spectrographs are now re-examining every bit of data from 3I Atlas, looking for these hidden patterns. The hunt is on for a fingerprint that says someone was here, and they wanted to be found. The story of 3I Atlas leaves us at a profound crossroads. On one hand, we may be witnessing an undiscovered violent natural process, a kilonova or an asymmetric supernova capable of creating alloys we once thought impossible. On the other hand, the combination of inexplicable metals, extreme chemistry, and a statistically improbable trajectory has forced serious scientists like Avi Loeb to consider an engineered origin. This isn't just a theoretical debate, it's a real object with real data that is breaking our models of the universe. Either way, our understanding has to expand. Don't forget to like, subscribe, and hit the bell icon for more deep dives into cosmic mysteries. Thanks for watching Space Facts. What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that defied the laws of physics. Data leaked by a ghost-like hacker group, revealing a 26-kilometer-wide object that wasn't just passing through our solar system, but actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. Let's delve into the data. Event Horizon cyber attack. How does a secret stay buried in the digital age? Sometimes it doesn't. In the dead of night on September 2nd, 2025, a hacker collective calling themselves Event Horizon executed a flawless cyber attack on NASA. They didn't just knock on the door, they dismantled it. By exploiting a zero-day vulnerability in an outdated mission planning module, they bypassed layers of federal firewalls. Security logs, later leaked themselves, show a terrifying timeline. At 3:14 a.m. Eastern, initial access was gained. By 3:19 they had escalated their privileges to the highest level. At 3:23, the exfiltration began. In less than 7 minutes, 24 gigabytes of compressed files were siphoned from a secure server containing mission telemetry, internal communications, and top-secret analysis on Object 3Y Atlas. By 3:30, they were gone. The attackers left no signature, no digital fingerprints, only a silent void in the server logs where critical audit trails should have been. The specific target was a data archive tied to the Deep Space Network, containing the most sensitive raw telemetry. NASA's internal cyber forensics team was left with nothing but a clean exit, a ghost in the machine that had walked out with the crown jewels. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. How can we be sure these leaks are real? The proof is in the details. The screenshots that flooded encrypted channels are layered with evidence of their origin. Documents are stamped confidential in bold block letters. Metadata tags show a 0314 UTC timestamp, matching the breach window from NASA's own security audit. A mission patch appears in the corner, a stylized comet streaking past a NASA vector, flanked by the code 3I Atlas int. One partially blurred memo lists the object's trajectory with terrifying numbers, hyperbolic v-infinity of 26.1 kilometers per second and an eccentricity, or E, of 6.2. These figures confirm an interstellar origin at a speed that defies simple explanation. Another screenshot shows a status log from the intercept team. Most text is blacked out except for a single phrase: plume anomaly flagged at T plus 11.3 seconds. The documents include FITS file headers for raw imaging data and internal routing codes for JPL's document management system. These are the kinds of mundane, technical details that are nearly impossible to fake convincingly. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3Y Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep, the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here is where the data gets terrifying. The trajectory of 3I Atlas was not just interstellar, it was unnatural. Calculations from the Minor Planet Center confirmed by JPL revealed an orbital eccentricity of over 6. For context, most comets from our own Oort cloud barely reach an eccentricity of 1.0. Our first interstellar visitor, Oumuamua, had an eccentricity of 1.2. A value of 6.2 means the object was moving on an almost perfectly straight line at a velocity that gravity could barely alter. But the most damning piece of evidence detailed in the leaked mission logs was a sudden, unexplained sideways acceleration on July 18, 2025. it was a course correction. The object wasn't just flying, it was steering. The maneuver required a change in velocity, or delta V, that would have required gigatons of force to achieve on an object of this mass. All natural explanations, outgassing, solar radiation pressure, even a gravitational assist from an unknown planet, were systematically modeled and ruled out by JPL's top analysts. The physics simply didn't work unless the push came from within. Surface anomalies. The armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67 P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. This is where the data points directly to active technology. Martin Cordner's team at Goddard Space Flight Center, a name appearing in the leak, got a full infrared spectrum of 3I Atlas. The data was so sensitive it was sealed within hours under a restricted embargo. The logs show the Webb Telescope's infrared array recorded heat vents pulsing with the regularity of a clock every 90 seconds. Heat would pool along the radiator seams and then burst outward in tight, directed jets, not the broad, chaotic outgassing of a comet. The mission logs label this a directive motion event, a term usually reserved for spacecraft thrusters. More disturbing, trajectory analysts correlated these thermal pulses with the object's subtle course corrections. Each 90-second heat pulse matched a tiny, precise adjustment needed to maintain its hyperbolic escape route. The focused nature of these thermal events implies the existence of engineered nozzles or vents, as a natural body's heat would dissipate uniformly across its surface according to the laws of thermodynamics. This was controlled, focused, and undeniably artificial. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%, a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Did we ever try to listen? According to the leaked files, yes. And what we heard was terrifying. While public-facing projects might report silence, the classified logs from the Deep Space Network told a different story. Radio astronomers reviewing the Intercept mission's raw data flagged a pattern that shouldn't have been there, faint, repeating echoes bouncing back from the object at regular intervals. These were not natural radio bursts or cosmic static. They were precise, clipped signals echoing at intervals that mapped almost perfectly to the 90-second timing of the object's thermal pulses. A veteran telemetry specialist named Marissa Singh, in a chat log later leaked by Event Horizon, wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." The return signal wasn't a simple reflection. It was modulated, carrying a complex phase shift. It was, for all intents and purposes, a reply. This suggested the object was not just passive, but an active system processing and responding to incoming stimuli. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So what does this all mean? We have a fictional but detailed account of an interstellar object, 3I Atlas, discovered in 2025. And we have a leaked cache of alleged NASA documents that point to a disturbing conclusion, that the object was a piece of technology. Metallic armor, rhythmic heat pulses that act as thrusters, refined nickel, and structured radio echoes all point to an artificial origin. The most shocking piece of evidence, a microscopic fragment that resembles a computer chip, pushes this story from science fiction into something far more unsettling. While the leak itself is part of this narrative, it forces us to ask a terrifying question. What if our first definitive contact isn't a message but a 26-kilometer machine flying silently past our window? The truth is still out there. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching InnoVision Tech. Could an object speeding through our solar system from the void between the stars actually be an alien spacecraft? On July 1, 2025, a mysterious visitor designated 3Y Atlas was discovered, sparking a fierce debate. Was it a natural comet, or the first definitive proof of extraterrestrial technology? One prominent Harvard scientist fanned the flames of speculation, while NASA pushed back with hard data. What followed was a clash between radical ideas and rigorous evidence. Let's explore this together. The Atlas discovery in Chile. So how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1, a definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3I Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. But what if a new discovery doesn't fit neatly into our existing boxes? This is where science can get heated. Enter Avi Loeb, a Harvard astrophysicist and the head of the Galileo Project, an initiative dedicated to searching for evidence of extraterrestrial technology. Having previously sparked debate by suggesting the first interstellar object, Oumuamua, could be artificial due to its observed non-gravitational acceleration, Loeb turned his attention to 3I Atlas. He pointed to its early lack of a visible tail and what he described as a trajectory that might eventually show subtle deviations not caused by gravity. In a paper released on the ArXiv preprint server, a common practice for rapidly disseminating new ideas, he proposed his radical hypothesis. If the object continued to show no outgassing, it might be a technological artifact. He even raised the hypothetical possibility of malign intent, suggesting it could use the sun for a gravitational slingshot to alter its course towards an undisclosed target. Loeb was careful to frame this as an intellectual exercise, admitting a natural comet was the simpler explanation. Still, the mere mention of alien technology from a scientist of his stature was enough to ignite a global media firestorm and put serious pressure on the astronomical community to respond. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. When a claim is that big, you really need the world's premier space agency to weigh in. So how did NASA approach the mystery of 3I Atlas? Well, they didn't rely on just a single instrument. Instead, they launched a coordinated, multifaceted observation campaign, allocating dozens of hours of precious observation time on their flagship observatories. This involved the Hubble Space Telescope, using its Wide-Field Camera 3 to capture incredibly detailed visible light images, and the James Webb Space Telescope, using its NIRSPEC instrument to analyze the object's infrared light for chemical signatures. A network of powerful ground-based observatories, like the Keck Observatory in Hawaii with its massive 10-meter twin telescopes, also joined the effort to track it continuously. This wasn't just about taking pictures. The goal was a deep analysis under the guidance of experts like Dr. Karen Meach, a leading astrobiologist renowned for her work on distant comets. This comprehensive approach was designed to replace speculation with an overwhelming body of evidence. NASA's mission was clear: to determine, with the highest possible degree of scientific certainty, the true nature of this interstellar visitor and let the data tell the real story. Comet behavior confirmed. So what does a comet actually do when it gets close to the sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3I Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet, reacting to the sun's energy. Its initial lack of a tail was simply because it was too far from the sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. Here's what really matters. You can learn a lot about something by the light it gives off. Using a technique called spectroscopy, a team of astrochemists led by a figure like Dr. Stephanie Malam from NASA's Goddard Space Flight Center analyzed the chemical makeup of 3I Atlas. This process is like a cosmic fingerprint analysis, where light from the comet's coma is split into a spectrum, revealing the distinct signatures of the molecules within it. The analysis confirmed the presence of water ice, but it was the other volatiles that were truly telling. They found a carbon dioxide to water ratio of 0.6, nearly double the average for comets in our solar system. The data from JWST also revealed significant amounts of carbon monoxide and traces of diatomic carbon, the molecule responsible for giving many comets their distinctive green glow. Far from being evidence of artificial design, these unique chemical traits told a story of its origins. The high CO2 content suggested that 3I Atlas formed in a brutally cold region of its home star system, much farther from its parent star than where our own comets were born. It was a pristine sample from a truly alien yet completely natural environment. Trajectory and safety assessment. With all the talk of alien technology and malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. But what about the unusual traits that sparked the controversy in the first place? It's important to remember that in astronomy, unusual does not automatically mean unnatural or artificial. Comets, even the ones from our own solar system, are, notoriously unpredictable. To provide some context, NASA pointed to historical examples like Comet 17P Holmes. Back in 2007, that comet suddenly brightened by a factor of nearly 1 million in less than 48 hours, totally shocking astronomers as it briefly became the largest object in the solar system by volume. This was a completely natural outburst, not an artificial maneuver. Cometary physicists like Dr. Michael Kelly from the University of Maryland explain that these events happen when sunlight penetrates a comet's crust and hits a pocket of supervolatile ice, like frozen carbon monoxide, causing it to flash sublimate and release enormous amounts of gas and dust. These anomalies are not evidence of intelligent control, they are actually a normal and expected part of cometary physics. The strange initial behavior of 3I Atlas wasn't a sign of technology, it was a sign that it was a dynamic natural object. Scientific value of interstellar visitors. So, if it's not an alien ship, why is 3I Atlas still such a big deal? Well, because its scientific value is immense. Every interstellar object that passes through our solar system is like a pristine time capsule delivered from another star. These objects carry the unique chemical and physical fingerprints of the planetary nursery where they were born. The high concentration of carbon dioxide in 3I Atlas tells us it likely formed in an incredibly cold, distant region of its home system. Some studies even suggest it could have originated in the Milky Way's thick disk, a population of older stars, making the comet potentially over 7 billion years old, actually predating the formation of our own sun and planets. Scientists could test this hypothesis by analyzing its isotopic ratios, for instance, the ratio of carbon-12 to carbon-13, and comparing it to other stellar populations. That makes it more than just a passing rock. It's a preserved fragment from the dawn of another world, providing invaluable data for our models of galactic chemical evolution. Comparing 3 interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3I Atlas was the third interstellar object detected, and it's fascinating how different all 3 have been. The first, 1E Oumuamua, was highly anomalous, rocky, appearing to have an extreme 10:1 aspect ratio, and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide to water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are, an outlier. In the end, Comet 3. I-Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Space Facts. An object from beyond our sun barreled through the inner solar system on October 19, 2017, moving so fast it couldn't possibly have come from here. Astronomers named it Oumuamua, messenger from afar, and soon realized its brightness was flipping tenfold every 8 hours, hinting at a shape unlike any natural body we've ever seen. Oumuamua initial detection. A cosmic intruder just crashed our solar system's private party, and it came from another star. On October 19, 2017, astronomer Robert Warwick was scanning telescope data at the University of Hawaii when he spotted something that shouldn't exist, a fast-moving object that didn't belong to our neighborhood. The Pan-STARRS 1 telescope had captured humanity's first glimpse of an interstellar visitor, something that had traveled for millions of years through the void between stars just to reach us. What made this discovery so extraordinary wasn't just the object itself but the incredible timing. Scientists estimate that only one interstellar object passes through our solar system every few years, and most are just too small or too fast to detect. Scientists quickly realized this wasn't space junk or a rogue asteroid from our own system. The trajectory was all wrong, the speed was incredible, and the direction it came from pointed to deep space. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar, because it truly was our first confirmed messenger from another star system. The discovery process itself was remarkable. Warwick initially thought it might be an error in the data until he tracked the object across multiple images. Within days of discovery, telescopes around the world were frantically tracking this mysterious visitor as it raced through our solar system at 26 kilometers per second. The Minor Planet Center in Cambridge immediately issued alerts to observatories worldwide, triggering an unprecedented international collaboration. The object was already past its closest approach to the Sun and heading back into interstellar space, giving scientists only a brief window to study it before it disappeared forever into the cosmic dark. What they found would challenge everything we thought we knew about space rocks, comets, and the possibility that we might not be alone in the universe. This cosmic messenger was about to rewrite the textbooks and spark debates that continue today. Classification challenges. Scientists love putting things in neat categories, but Oumuamua refused to play by the rules and turned astronomical classification into chaos. Initially classified as Comet C/2017 U1 on October 25, 2017, researchers expected to see the classic signs: a glowing tail, a fuzzy coma of gas and dust as ice sublimated near the sun. Comets are essentially dirty snowballs that light up beautifully as they approach our star, creating spectacular displays that have inspired humans for millennia. But Oumuamua was having none of it. No tail, no coma, no visible outgassing whatsoever, even though it had passed closer to the Sun than Mercury's orbit. This was like expecting a snowball to melt in a furnace and finding it completely unchanged. Confused astronomers quickly reclassified it as Asteroid A/2017 U1, but that didn't feel right either. Traditional asteroids are rocky or metallic chunks left over from planetary formation, and they follow predictable patterns based on billions of years of observation. But Oumuamua's behavior was inconsistent with known asteroid properties. Its rotation rate, brightness variations, and movement patterns all suggested something fundamentally different. By November 2017, the International Astronomical Union faced an unprecedented problem and created an entirely new classification system just for Oumuamua, designating it 1I/2017 U1, the I standing for interstellar. This was the first time in astronomical history that a completely new category had to be invented for a single object, highlighting just how unprepared science was for visitors from other star systems. The classification headache revealed something profound. Our understanding of cosmic objects was based entirely on things that originated in our solar system, shaped by our sun's gravity and radiation over 4.6 billion years. Oumuamua was playing by different rules written in another star system billions of years ago under completely different conditions. Its refusal to fit into existing categories was the first hint that this visitor was unlike anything we'd ever encountered. And scientists began to realize they weren't just looking at a space rock, they were examining an alien artifact from deep space. Trajectory analysis. Tracking Oumuamua's path through space was like following breadcrumbs back to another world, and the story it told was absolutely mind-blowing. Astronomers used precise measurements from observatories worldwide, including the Very Large Telescope in Chile and the Gemini Observatory in Hawaii, to reconstruct its journey with incredible accuracy. What they found was a cosmic wanderer that had been drifting through interstellar space for millions of years before accidentally stumbling into our solar system like a lost traveler finding civilization. Dr. Marco Micheli and his team at the European Space Agency traced its origin to the general direction of the constellation Lyra, specifically toward the star Vega, one of the brightest stars in our night sky. But here's the incredible part. Even if it came directly from Vega, it would have taken 600,000 years to make the journey, meaning this object began its voyage when early humans were just learning to control fire. The trajectory analysis revealed that Oumuamua wasn't bound to any particular star system. It was a true galactic wanderer that had been drifting through the local standard of rest, the average motion of stars in our galactic neighborhood. The object entered our solar system from above the plane where planets orbit, approaching at a steep 122-degree angle that no local object could achieve. This approach angle was like a cosmic signature proving its interstellar origin beyond any doubt. Its hyperbolic trajectory meant it was moving too fast to be captured by the sun's gravity. This was a true flyby mission with no possibility of return. The orbital calculations revealed Oumuamua came within 0.25 astronomical units of the Sun on September 9, 2017, closer than Mercury's orbit, experiencing temperatures of over 300 degrees Celsius before being flung back toward interstellar space by gravitational slingshot effects. By the time astronomers discovered it in October, it was already racing away at 44 kilometers per second relative to the Sun, fast enough to travel from Earth to the Moon in just over 2 hours. The trajectory analysis proved beyond doubt that this was our first confirmed visitor from another star system, a cosmic time capsule that had witnessed the birth and death of distant worlds, survived the radiation of interstellar space, and arrived at our doorstep carrying secrets from the galaxy beyond. Photometry and shape analysis. So, photometry and shape analysis showed that Oumuamua was doing something no space rock should do. It was flashing like a cosmic lighthouse. Photometric observations from multiple telescopes revealed that the object's brightness varied by an extraordinary factor of 10 every 7.3 hours as it tumbled through space. This dramatic brightness change suggested something unprecedented, an object so elongated that it was unlike anything in our solar system. Dr. Karen Meach from the University of Hawaii led the analysis, calculating that Oumuamua was at least 10 times longer than it was wide. Imagine a cosmic cigar, or maybe a football spinning end over end. Some models even suggested it could be more extreme, possibly a 20-to-1 length-to-width ratio. But Dr. Sergei Moshchenko proposed an alternative. What if it wasn't cigar-shaped but pancake-shaped? A flat, disc-like object could also produce the same brightness variations. The tumbling period was unusual too. Most asteroids rotate much faster, but Oumuamua's leisurely spin suggested it might be held together by something other than typical rocky materials. The photometric data painted a picture of an object so bizarre that it challenged our understanding of how planetary formation works. No known process in our solar system creates objects with such extreme dimensions. This wasn't just unusual, it was honestly geometrically impossible, according to everything we knew about how gravity shapes space rocks. Oumuamua was, in a sense, rewriting the rules of cosmic architecture. Acceleration anomaly. And then, there was the acceleration anomaly. Oumuamua just broke physics, and scientists are still trying to figure out how. As telescopes tracked the object's movement away from the sun, something impossible happened. It started accelerating faster than gravity alone could explain. Dr. Marco Micheli's team at ESA first detected this non-gravitational acceleration in June 2018, analyzing data from the Hubble Space Telescope and ground-based observatories. The acceleration was tiny, only about 0.00005 meters per second squared, but it was real and measurable. For comparison, if you dropped a feather and it fell upward instead of down, that would be less surprising than what Oumuamua was doing. In our solar system, when objects accelerate away from the sun without gravitational explanation, it's usually because they're comets releasing gas and dust that creates a rocket-like thrust. But Oumuamua showed no signs of such outgassing. No tail, no coma, nothing visible that could explain the extra push. The acceleration was also pointing in exactly the right direction, directly away from the sun, which made it even more mysterious. Professional astronomers ran the calculations dozens of times, checked their instruments, and consulted with colleagues worldwide. The result was always the same. Oumuamua was being pushed by an invisible force. This single observation transformed a curious interstellar visitor into one of the most puzzling objects ever detected, launching 1,000 scientific theories and capturing the imagination of anyone who wondered if we might not be alone. Spitzer observations. NASA brought out the big guns to solve the Oumuamua mystery, and what they found made everything more confusing. The Spitzer Space Telescope, with its incredibly sensitive infrared detectors, was humanity's best hope for detecting any invisible outgassing that might explain the object's mysterious acceleration. Dr. David Trilling from Northern Arizona University led the observations in November 2017, pointing Spitzer's instruments at Oumuamua as it raced away from the inner solar system. Infrared telescopes can detect heat signatures from sublimating ice and microscopic dust particles that are completely invisible to optical telescopes. If Oumuamua was secretly behaving like a comet, Spitzer would catch it red-handed. The results were published in the Astronomical Journal in 2018, and they were as puzzling as they were definitive. Nothing. Absolutely nothing. Spitzer's upper limits on dust and gas production were so strict that they ruled out traditional cometary activity by orders of magnitude. If Oumuamua was releasing material to create thrust, it was doing so at levels 10,000 times lower than typical comets. This wasn't just unusual, it was physically implausible. The Spitzer observations eliminated the most obvious explanation for the acceleration anomaly and forced scientists to consider more exotic possibilities. Either Oumuamua was made of materials that don't exist in our solar system, or it was being pushed by forces that we don't understand, or, well, it wasn't natural at all. Artificial origin hypothesis. So here's the thing. Harvard astronomer Dr. Avi Loeb dropped a scientific bombshell that made headlines worldwide and honestly divided the astronomy community. Back in October 2018, Loeb and his postdoc Dr. Shmuel Bialy published a paper suggesting that Oumuamua might not be a natural object at all. It could actually be artificial technology created by an alien civilization. Their hypothesis, which was published in the astrophysical journal Letters, proposed that Oumuamua was a light sail, an ultra-thin sheet of material designed to be pushed by radiation pressure from stars. This idea would explain both its unusual shape and the mysterious acceleration, without needing any detectable outgassing. And, light sails are real technology that humans are developing for interstellar missions, so the physics behind it was actually sound. Loeb calculated that an object only millimeters thick, but hundreds of meters wide could behave exactly like Oumuamua, accelerating away from the sun as starlight pushed against its surface. The paper, as you might imagine, sparked fierce debate in the scientific community. Critics argued that invoking alien technology violated Occam's razor, the principle that simpler explanations are usually correct. But Loeb countered that the scientific method requires considering all possibilities, even the uncomfortable ones. His 2021 book, Extraterrestrial, further developed this hypothesis, arguing that scientists' reluctance to consider artificial origins was more about sociology than science. Whether he's right or wrong, Loeb's proposal really forced astronomers to think outside conventional boundaries, and consider that our first interstellar visitor might have been our first contact with alien engineering. Dark comet theory. So scientists found a kind of middle ground between the idea of a normal space rock and the more far-out theory of an alien spacecraft. and it's called the dark comet hypothesis. Dr. Darryl Seligman from the University of Chicago, along with his colleagues, actually proposed back in 2019 that Oumuamua belonged to a previously unknown class of objects that behave a lot like comets but basically remain invisible to us. These so-called dark comets would have just enough ice to create the non-gravitational acceleration we saw, through a process called sublimation, but at levels so low that our instruments just couldn't pick up the outgassing. The theory suggested that Oumuamua was made of materials that had been altered by billions of years of exposure to cosmic radiation out there in interstellar space. This kind of space weathering could create a dark, carbon-rich crust that would hide any ice underneath and make the object look a lot more like an asteroid than a comet. Computer simulations even showed that tiny amounts of sublimating hydrogen gas, basically invisible to most telescopes, could produce exactly the kind of acceleration that was observed. The dark comet model explained Oumuamua's behavior without needing to invoke exotic physics, or, alien intervention. It also suggested that interstellar space might actually be filled with these mysterious objects, failed comets, planetary fragments, or debris from destroyed worlds that have been wandering between the stars for eons. The hypothesis gained even more credibility when astronomers began finding similar objects right here in our own solar system. Small bodies with mysterious accelerations but no visible outgassing. So, Oumuamua might not be unique after all. Maybe it's just the first representative of a hidden population of dark wanderers that populate the galaxy. Dark comet classification. The mystery of Oumuamua got even more interesting when astronomers started spotting similar objects basically hiding in plain sight within our own solar system. In 2023, Dr. Darryl Seligman and his team published some pretty groundbreaking research identifying 7 near-Earth objects that showed the same puzzling behavior: non-gravitational acceleration without any visible outgassing. These objects, now officially classified as dark comets, provided the missing link in understanding Oumuamua's true nature. The research published in the journal Icarus actually revealed 2 distinct populations of dark comets in our solar system. Outer dark comets like 2003 RM and 2010 BK118 follow eccentric orbits similar to traditional comets but show no visible activity. Inner dark comets, like 2007 VA85, orbit closer to the Sun and tend to be smaller, which suggests different formation mechanisms or evolutionary histories. This discovery was honestly revolutionary because it meant dark comets weren't just rare interstellar oddities. They were a previously unrecognized population that had been masquerading as asteroids for decades. The new classification system distinguished them from regular comets and asteroids based on their orbital dynamics and the lack of any detectable coma or tail, despite clear evidence of non-gravitational forces at work. Finding dark comets in our own solar system strongly supported the idea that Oumuamua belonged to this category. It suggested that these kinds of objects might actually be common throughout the galaxy. Invisible wanderers moving between star systems, maybe even carrying ice and organic materials that could seed life on distant worlds. The dark comet classification really transformed Oumuamua from a unique anomaly into the first confirmed member of a whole cosmic population we never even knew existed. Scientific debate. 5 years after Oumuamua's flyby, the scientific community is still, fascinatingly divided. And that's actually how science should work. Multiple competing theories keep battling it out in peer-reviewed journals, with each one having some pretty compelling evidence and passionate supporters. The mainstream scientific consensus has gradually shifted toward the dark comet explanation, with researchers like Dr. Jennifer Bergner from the University of California, Berkeley publishing detailed models in 2023, showing how hydrogen outgassing could explain every observed characteristic of Oumuamua. Meanwhile, Dr. Avi Loeb continues to push for the artificial origin hypothesis, launching the Galileo project to search for similar objects and develop new detection methods for potential techno-signatures. Some conservative astronomers prefer explanations involving exotic but natural processes. Maybe Oumuamua was a fragment of a nitrogen iceberg from a Pluto-like world, as Dr. Alan Fitzsimmons proposed back in 2021. The debate has actually produced over 200 scientific papers since 2017, each one adding new pieces to the puzzle. What makes this controversy especially valuable is that it's driving innovation in observational astronomy and interstellar object detection. Projects like the Vera Rubin Observatory, which is set to begin operations in 2024, will discover hundreds of interstellar visitors in the coming decade. The European Space Agency's proposed Comet Interceptor mission could even rendezvous with the next Oumuamua-like object. No matter which theory ends up being correct, Oumuamua has fundamentally changed our perspective on the solar system's place in the galaxy, and reminded us that the universe still holds some pretty profound mysteries waiting to be solved. Alright, that's a wrap on Oumuamua's mind-bending mystery. This interstellar visitor really challenged everything we thought we knew about space objects and honestly left us with more questions than answers. Was it a dark comet, alien technology, or something else entirely? The truth is still out there, just waiting to be discovered. So, what do you think Oumuamua really was? Drop your theories in the comments below. I actually read every single one. And hey, if you're hungry for more cosmic mysteries and space facts that'll totally blow your mind, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries. The universe is full of secrets, and we're just getting started uncovering them together here at Space Facts.